Hello friend, in this lecture number 29, we will discuss about ready to serve and ready to drink fruits and vegetables beverages. The concept that will be discussed in this lecture include fruit and vegetable beverages, their type and characteristics, ready to serve drinks, squashes, cordials, nectars, crush and fruit syrups, their manufacturing technologies and formulation, and carbonated fruit beverages. Okay. So, let us see first what a beverage is. That liquids or food consumed in the liquid state are considered beverage. They contain stimulant or flavoring agents which perform some useful function in the body, but they are not essential for proper functioning of the body, particularly those beverages, the soft drinks etc., which are available plenty in the market and they are used. So, they are the soft drinks or soft beverages, they are generally used to quench the thirst. However, but fruits and vegetable beverages, they do contain good amount of micronutrients and bioactives, because these foods and vegetables, and therefore, there is a trend now consuming more and more fruits, beverages, vegetable juices etc., rather than going for the general carbonated soft drinks. The beverages can be classified generally into two categories. One may be alcoholic and fermented beverages, and the other category is the non-alcoholic or unfermented beverages. So, alcoholic and fermented fruits beverages or vegetable beverages we will take up separately in other module. In today's class, we will especially discuss about non-alcoholic or unfermented fruit and vegetable beverages, and these include different products available in the market like juices, ready to serve drinks, squashes, crush, syrups, cordials, concentrates, nectar or carbonated beverages and so on. Okay. Ready to serve beverage, it is a non-fermented beverage prepared from mixing edible portion of a fruit, sugar, water and additives for direct consumption. Some fruits have high nutritional content, but they are bitter or astringent, like tannins and such other polyphenols etc. might be present in them. So, they make them unable to consume directly. So, such fruits can be converted into this type of beverage by mixing other components and they can be consumed. So, two or more fruits or vegetable juices can be blended together at definite proportions using proper mass and material balance techniques, and also properly balancing their sensory characteristics like color, flavor, taste etc. So, appropriate blends can be made, and this blending of fruit juices basically increases the taste, flavor, aroma, nutrient properties, and also many a times they give good shelf life, because the fruits are vegetable, like vegetables are generally they are low acid. So, there may be more contamination chances. So, if this a vegetable is selected and there is a fruit which has more acid or which has more sugar. So, if they are mixed together, their juices etc. So, there may be improvement in the taste, aroma, even shelf life also, because acidity, sugar content may help the vegetable use. But however, while selecting these for blending, okay, that proper sensory blending, it is more important. That is they should, their sensory characteristics, color, flavor should match to each other, and the blend which you are getting, you should get a good characteristics in the beverage. As per the FSSAI guidelines, the different types of non-alcoholic fruit beverages etc. are that given in this table. That is the type of beverage like ready to serve beverage. It should contain pulp or juice concentration up to 10%. Total soluble solids should be 10%. its acidity should be 0.3 and it should contain preservative maximum 70 ppm sulfur dioxide. Squashes, normally they contain 25% pulp or juice concentration, its TSS is 40, acidity 3.5 and they can have preservative up to 350 ppm of sulfur dioxide. It contains 25% pulp, about 55% total soluble solids, its acidity is 3.5 and it has around 350 ppm sulfur dioxide. Similarly, cordials and pulps also. Pulp, it has 100% pulp and it may contain up to 1500 ppm sulfur dioxide. Okay. The total plate count of all these products should not exceed to 50 CPU per ml, that is 50 colony forming unit, and yeast and mold count should not exceed to 2 colony forming unit per ml, and the coliform count should be nil in 100 ml beverage samples as per the FSSAI guideline. So, ready to serve mango drink, we will take up now on some important fruit drinks. So, mango is the most common tropical fruit found in India. Due to its rich flavor, fragrance and taste, it is liked by the people of all age groups and thus it is known as the king of all fruits. So, mango pulp tastes sweet, it is suitable and direct eating and drinking of its juice is followed. So, the various ingredients for the RTS mango drink are the mango pulp, sugar, water, preservatives and flavors. Okay. So, that obviously the water is the most important component of any beverage. So, the quality of the water which is used to manufacture the beverage is of prime importance and much attention is given to its treatment before use and to its behavior in relation to the other constituents, particularly the fruit juice or in the fruit pulp, what are the components, flavoring components, etc. which is, so the water it should be free from any solid sediments, etc. The water which may be satisfactory for household drinking purposes may not be suitable for beverage manufacture. Okay. So, generally the water is extra pure water is used for any beverage preparation, whether it is RTS mango beverage or any such other beverage. So, generally the water is subjected to a sequence of pre-treatments including chlorination, treatment with lime and or activated carbon, coagulation, sedimentation, sand filtration, etc. The purpose is it should not contain any suspended, colloidally suspended dissolved solids, etc. Otherwise, it may have unnecessary unwanted reaction with the flavoring components, coloring components of the juices, etc. and the problem. So, one should take care of. So, this is the process flow chart for RTS mango beverage manufacturing. Various in the figure here we have shown various brands which are available commercially in the market, and this other line like in the earlier classes lectures we have seen up to the pulping and extraction. So, the same things will follow here. So, after you get the pulp or if you get the juice of the desired soluble solids, desired bricks, that it is filtered or clarified and then clarified pulp or juice as the clarified juice, pulp of desired degree of soluble solids and total solids is taken and here in the mixed with the sugar syrup. It is sent to the mixing tank where, and that is here very important, that is now in the RTS mango beverage, what type of characteristics you want in the beverage, whether you want a clear transparent juice or if you want some solids content in it or some mango solids content. So, depending upon that what is your requirement, accordingly you can have a proper material and mass balance. You can use simple mathematical calculations. For example, if you have a pulp content having 20% total solids and if you want to make here the juice having or pulp have 20% total soluble solids and you want it to make a juice having that is 5% total soluble solids. So, how much water is to be added, that you can calculate Okay. Accordingly, if you want to make it sweet, so what is the degree of sweetness, and so how this sugar TSS level and all. So all these consideration one can do. There are simple mathematical equations one can follow and use the material. But the important thing is that it is not only just material balance, one should also take that while doing the material balance, at least sensory characteristics are maintained to the desired level. So after this is done, this is, so you can say, and most of the manufacturer, they follow, there are the trade secret, that is the commercial secret, that is how they are formulating, what are the various preservatives etc. they are using, because that is their brand secret. So and the rest thing is common for any beverage. So after it is mixed properly, then this RTS mango beverage is pasteurized at 80 degrees Celsius for 10 minutes, it is cooled down and sent to the aseptic packaging line. Aseptic packaging and processing already we have discussed in earlier lecture. Okay. These are some of the equipment, then the factory line, how it is shown that is the even mango is going in the conveyor belt, then it is de-stoned and washed properly, so pulp is extracted, and then this pulp is kept in the container etc. from where it is sent to the packaging line, aseptic processing, packaging, filling, mixing. These are the equipments which are used. So this I have told that is particularly for the mango pulp, but these are the same equipment can be used for other such fruits and vegetables as well, like elevator, sorter, brush and spray cleaner, peeler, pulper, juice extractor, okay, or juice fine filter, pasteurizer, and then aseptic packaging units. So almost all the fruits and vegetable juice processing and packaging line, there may be single little bit here and there some addition or deletion depending upon the particular characteristics of the fruit or vegetable. Otherwise, these are the most common. So here in this table I have given some the literature report the people have worked, that is on the blending of the RTS, blended RTS beverages, like Jayachandran et al. In 2016, they reported that lychee juice with coconut water and lime juice blending in the proportion of 72, 27 and 1%, and they reported it was found better tasting, and also there was a better enzyme inactivation than the pure lychee juice, enzymatic stability you can say. Okay. Then Roy et al. They reported the cashew apple was blended with the fruits like mango, pineapple and sapota for the value addition. Okay, Sarkar and this Bulu, they mixed guava juice with pineapple in the ratio of 60:40, and this gave best organoleptic properties and physical chemical properties according to them. Then Sharma et al. In 2017, they reported blending of jamun fruit with the sour mango juices etc., and this is done to reduce the poor or sour taste of the mango juice and high acidity. So blend gives a better tasting beverage. Aloe vera, ginger and amla were mixed together, and the consumer liked this beverage according to the Shashi Kumar et al. Okay. Mane et al. In 2018, they reported that 20% turmeric was added in orange juice to enhance the nutritional value, and it was highly appreciated by sensory panels etc. So there are many such even now these blended RTS beverages are available in the market also. So the one aspect is in these RTS RTD beverages L2 is the addition of enzymes. In the earlier class also, when we were studying the juice preparation and clarification etc., there we have seen the role the enzymes play. That is, enzymes are such as pectinases etc., they are added into the RTS and blend before filtration process to increase the juice yield as well as to clarify the juice. So the pectinases degrades the polysaccharides present in the pulp. Okay. This making them into smaller fractions and then facilitating the filtration process. Similarly, other enzymes as well can be used depending upon what are the different contents present in the juice or in the pulp. Okay. So obviously, the benefit of adding using the enzyme is manifold, like for example, there is a increased juice yield, improved juice filtration efficiency, improved juice stability and concentration, there is enhanced juice clarity and reduced bitterness of the juice. Okay. This addition of enzyme in the blended RTS drink, that is reported, that is 50 ratio, the orange juice is blended in the mango juice. Okay. And in the process line you can see that is after the mango pulp. Okay. In this orange juice is blended in the ratio of 50-50, and then the enzyme, pectinase enzyme is added here, appropriate amount of the pectinase, and the temperature is maintained around 40 degrees Celsius or even 37 to 40, 35, and it is maintained for 24 hours. That is the proper time is given for the enzyme to act. So, whatever the suspended polysaccharides etc. might be there in the juice, these enzyme, pectinase enzymes etc., they dissolve them and they break them into soluble components and hydrolyze them, and then it is removed by filtration. The juice is then filtered, pasteurized, cooled and packaged using either aseptic packaging line, other line which we already discussed in the earlier class. So, these were about RTS, RTD beverages. Then another category of the drink fruit beverage in the market is squash. These squashes are the concentrated fruit juices which should at least contain 25% fruit pulp and should have a minimum 40% TSS. So, it should be diluted before consumption. Squashes are usually fruit flavors. Okay. Earlier it was used for lemon, then lemon squash is very popular, lemon, orange squash etc., but now it has spread to other fruits as well. So, some of these fruits flavor include bale, orange, apple, black currant, pineapple, mango, lime and lemon. They are diluted in 1:4 ratio before their consumption. Here we are showing in the lychee squash preparation, that is you get the raw lychees using the earlier discussed techniques, that is the peeling and pulp. So, first step is the pulp. We get the lychee, whole lychee is converted into pulp. Then in the pulp, that is even citric acid can be used as a preservative. So, all these process, that is the sorting, grading, pulping, extraction etc., we have earlier studied. So, for the lychee squash preparation important, and similarly for any fruit, that is you get the pulp made using the standard technology that we discussed earlier, and then simultaneously you get the sugar syrup prepared. That is the sugar syrup is prepared at the hot steam jacketed kettle, all right, and the crystalline white sugar should be used for preparation of the sugar syrup, and heating of the sugar should be controlled. It should be done in such a way so that there is no browning or caramelization, otherwise it will adversely affect the color of the beverage squash. So, even sometimes some citric acid or some other things are used, clarifier is used to whiten the sugar syrup. So, good. And another thing important is, like in the squash you want that yes, it should contain 40% TSS. So, in the pulp you have prepared what is the amount of pulp, the TSS in the pulp, and accordingly you can see that up to what level of TSS content you can go into the sugar syrup. Accordingly calculated amount of sugar would be used and calculated amount of water. The quality of water we discussed earlier, good quality water should. So, you have prepared syrup, you now have the pulp, and then finally this is the process that syrup which is already added with the citric acid, it was preserved, then the pulp is added here and it is mixed, sugar syrup and pulp, and of course you have the proper mass and material balance. For example, if in the pulp, as I told you, if you are having 20% total soluble solids, in the sugar syrup you have 10% soluble solids, then you can what should be the quantity, it should be mixed, so that because the 25% pulp has to be there as per the requirement of the FSSAI etc. So, and that 25% what is the sugar level should be there, so that you can get 40% TSS, but while doing that, this simple mathematical calculation, you have to take into account the complex biochemical interactions, that is interactions of the different compounds which together mix, that is the sugar, how it is getting mixed and how the sensory characteristics getting where, that is it is being diluted, or so all those sensory characteristics. Then it is followed by filtration, preservatives may be added, packaged, and then aseptic processing line. Then the cordial is another category of product. It is a juice from which all the insoluble material are filtered. It is clear, sparkling, sweetened protein juice and is prepared from clarified juice. It should contain about 25% fruit pulp and 30° Brix TSS with preservative about 1.5% citric acid and 350 ppm sulfur dioxide. Lime and lemon are the most suitable for cordial making. They are generally blended together with wine for consumption. So, the process flow chart for cordial preparation. So, the juice extraction, lemon is used, and then this line we got the lemon juice. We have already discussed the earlier whole process. Then this juice is strained, preservatives are added. These are the clarified. Normally it is stored in a container for 10 days. So, this clear juice supernatant is taken, and whatever sediments etc. are there, they are filtered away, and then finally the strain, then sugar syrup, and it is mixed. So, this clear juice and mixed with the sugar syrup, preservatives are added, and it is packaged. Then crush is another product, that is process flow chart for the strawberry crush making, strawberries, sorting, washing, and then crushing. You have the crushed strawberries, okay, and then the sugar which boiled with water, sugar syrup, boiled sugar syrup, and then here are the crush and the sugar syrup is mixed. Mass and material balance is done to get the desired level of solids as well as total soluble solids, and then it is pasteurized, filled and stored, packaged. The another category is the nectar. Some fruits contain high acidity or fruit pulp which hinders the development of fruit juice, and thus they are made palatable by adding water and sugar, and they are known as nectar. These include the bulk currants, black currants, sour cherries and bananas. It contains fruit pulp, fruit fiber and pectin along with the sugars and preservatives. Nectar can also refer to the juice from fruit which is too thick to drink as it is. Examples of these are the juices from apricot, peaches, pears and so on. Nectar is thicker than fruit juice, and is it clear as smooth as a fresh fruit juice, and is needed to be diluted down. It should contain at least 20% fruit juice or pulp, 15% TSS and also about 0.3% acid. It is not diluted before serving. So, it is made in this proportion. Okay, process flow chart for making mango nectar preparation. Okay, so the mango heated, you get that mango pulp as per the procedure discussed in earlier classes, and then sugar, additives and acids etc. added here and mixed by properly, that is adjusting the material and mass and total soluble solids, and this sugar should be added to ensure the proper sweetness, acids and sugar balancing. All this balancing is done, all additive preservative. Then it is colloid mill for uniform homogeneous suspensions, you get a smooth product. Then degassing, any type of gas is removed etc. to prevent oxidation. Then it is filled at around 65° Celsius and sealed. So, that is the it is a care is taken that in the head space of the container there should not be any gas etc. Otherwise, it will create problem of that oxidation etc. of the product. So, finally, it is sterilized at 100° Celsius for 5 to 10 minutes and then cooled and storage. So, this is the process flow chart for the mango nectar preparation. Okay. Then fruit syrups, These fruit syrups are made by cooking fruit juice with sugar syrup to the consistency of syrup. Juices from fresh or frozen blueberries, cherries, grapes, raspberry, that is either black or red, and strawberries are easily made into toppings for use on ice balls, ice cream, pancakes and pastries, etc. Okay. This is the process flow chart. Like you have the appropriate juices of these strawberries, grapes, cherries, etc. and sugar syrup mixed properly, and then this is mixture is boiled to around 90 to 100 degrees Celsius, filtered, filled and cooled down and stored. So you get a fruit syrup. Okay. Then carbonated fruit beverages is another category. Now it is getting popular day by day. So carbonated soft drinks are just thirst quenching, as I told you in the beginning, and they have refreshing properties, but they lack nutrition. So the Indian government FSSAI in 2016 regularized the use of fruit pulp. That is, it is as per the requirement at least a minimum 5% of the fruit pulp in the carbonated beverages should be used to make them carbonated fruit drinks. So the purpose is the enhancement of the organoleptic properties as well as the nutritional value, but the it should be taken that since carbon dioxide is being used here, so that the taste of the fruits at least it should go side by side. So bitter fruits like amla, jamun, lime, etc., they may be better suited for use in this carbonated fruit beverages. Spices can also be used to enhance the sensory properties. The beverage could contain peel, oil or fruit essence or anything type of that. So this is the process flow chart of the carbonated fruit juice, fruit beverage making. So in this, actually this is the actual line of the making of the any carbonated soft drink. So for making carbonated soft drink, actually the sugar syrup is taken and synthetic flavors and synthetic colors and preservatives. So a mixture of synthetic, so a sugar emulsion is made, flavor and syrup, flavor, color and preservative emulsion, and this emulsion is added into the sugar syrup, and then it is a concentrated sugar syrup and it is diluted using the carbonated water. That is the carbonated water, or it is diluted with water and then carbonated under pressure given as 1 to 5 volume carbon dioxide pressure is given. So that is the general carbonated soft drink. But these synthetic flavors now, as per the regulation, that is they are replaced with the natural fruit flavors, that is either fruit syrup or fruit pulp or fruit juice, that is the natural. It is added in the place of synthetic color and flavor emulsion. The rest process remains almost the same. Okay. But however, this has certain challenges. There is the amount of this fruit, and if there should not be any unwanted reaction with the carbon dioxide and the flavoring components, coloring components of these fruit juices, etc., and they should have proper shelf life, that is during stability, that is storage, etc. The problems related to oxidation, etc., should be avoided. So these are the about. So now finally I will come to that is there are certain issues and challenges in ready to serve and ready to drink beverages. That is, issues are like, one is the settling problem. You might have observed in the squases, etc., that is which are the cold process making, that where particularly that the enzymes are pectin methylester enzymes, etc., are not inactivated properly, then these pectins during the storage of the juice, they work on the pectin methylesterase enzyme works on the pectin and it demethylates it, and demethylated pectin is becomes insolubilized and it settles in there. So as that is called the settling or serum separation problem. The other problem may be the conventional, if you give the heat treatment, conventional heat treatment for making beverage, it may result, it may have is adverse effect on the nutritional quality of the even conventional treatment for the extraction, even concentration, etc. It may have adverse effect on nutritional quality, sensory characteristics, bioactive components, and so on. Also the packaging problem, that is the packaging material if is not proper, that it may result to the oxidation related changes, browning changes, etc. So the packaging should be proper. Then demethylate and pectin, already told you that making the pectin insoluble in the drinks, so that they can be the possible solution is that yes, add pectinase enzymes for to take care of settling problems. Okay, that is some appropriate hurdle technology or other arrangements for activating, deactivating an enzyme to ensure that the product quality is maintained. Then aseptic or vacuum or nitrogen packaging should be encouraged to avoid the oxidation or browning or packaging related problems. So in order to have a better bioactives retention, better nutritional characteristics, better sensory characteristics in the product, the novel techniques such as high pressure processing, PEF, ultrasound, etc. should be encouraged during the extraction process as well as during the subsequent process further, that is the sterilization and aseptic system, etc. Okay. And the packaging, that is maybe active packaging, modified here in the case of juices and beverages, better nitrogen packaging, aseptic processing and packaging may work much better. Okay. So this, I think we come to the end of this lecture. That is the very important aspect is that is that these fruits and vegetable, that is ready to serve, ready to drink beverages, and the vegetable juices, etc., fruit juices, they are the hub of the nutrition, and then a trend is there toward the consumption of more and more fruit juices, more and more vegetable juices, so that you can get the health advantages. So in this category, there is to get a better health drinks, rather health beverages, fruits and vegetable ready to serve, but the care has to be taken. It should be minimally processed, so that the possible technological issues or proper care should be taken. So it is properly processed so that it has a sufficient shelf life to have a commercial value. At the same time, it has a good sensory and characteristics, and it has a good bioactives and health components. So these are the references used in this lecture. With this, thank you very much for your patience here.